Let's continue with electron beam melting. As you know, if you are using an electron beam, then you should be performing these operations in a vacuum atmosphere, and that is the same actually in this welding operation. And this time, with respect to the previous welding processes, the heat actually required for the welding operation is actually obtained with the help of the kinetic energy of the electrons which are hitting the workpiece. And with the help of them, the temperature of the parts are increased and they are joined together. The advantage of this electron beam welding is that we can easily join thicker work parts together, and their deep to width ratio might be quite high compared to other welding operations. And with this process, we can join any type of metals together. And as you know, we cannot have an extra equipment around. So without using any shielding gas, flux, or filler metal, we can join these parts together. Another advantage is that the heat effect zone is quite lower, small. You can see for us in this pictures that this is the heat effect zone of actually last tungsten arc welding, but now in this electron beam welding, the heat effect zone is very thin. So that is an important issue and advantage of such welding processes. And similar to electron beam welding, we have laser beam welding. As the name implies, we are using laser, and you know that we don't need to have vacuum for that type of welding operation. But obviously, the source of heat in this process is the laser itself. And if you focus it into a specific point and into a small area, then you may increase the density of energy and can easily join fuse some parts together. And again, as in the case of EBW, electron beam welding, this is again quite useful for deep and narrow actually welds. And the quality of the welds is quite good. We have, since the heat effect zone is less, we have minimum shrinkage, and the strength is again better. And we have ductile and less porous regions inside the weld. Now let's briefly compare these two processes together, laser beam welding and electron beam welding. First of all, in the laser beam welding, we don't need to use support, so it's a nice advantage. It can easily be automated since you can make, actually you can put this equipment at the tip of an robotic manipulator and make it an automated approach. But it's not possible for EBM. You need to have a fixed plate in the EBW process. This is a disadvantage of EBW. Another advantage of laser beam welding is that we are not generating any X-rays, and these are actually happening in electron beam welding. And lastly, the quality of the beam is much better in the laser beam welding process. We have less distortion, and there is no actually incomplete fusion or porous regions inside the laser beam welding processes. And lastly, we have a kind of an hybrid approach which utilizes laser beam welding, the principles of laser beam welding, and the principles of gas metal arc welding. So the thing is that, as you see in this sketch here, in addition to the gas metal arc welding basics, we have an extra beam here. With the help of it, these regions are easily melted. So with this one, you can actually join thicker parts together easily compared to the gas metal arc welding. And in addition to welding, actually, we may use similar torches, the torches we are using in welding for cutting purposes. Since we have heat source, with the help of it, we can melt some parts and then remove these material from the original workpiece. So that's not difficult actually to perform cutting operations with the equipment of welding operations. For instance, we have oxyfuel gas cutting, and this one, as the name implies, again, we are using some fuel and oxygen. With the help of them, the heat will be, we will have some combustion, heat will generate it, and with this heat, some part of the metal will be melted and they will be removed from the workpiece. And in this specific operation, what we do, for instance, in the cutting of iron and steels, what do we have? We have ferrous items and we have combustions, some reactions as you see after each other. And this is the first one. And with all of these, we generate some oxides. And these are ferrous oxide, as you see. And these are removed from the workpiece since they do not belong to the steel anymore. They are different type of molecules, so they are removed easily. And we also have some amount of, let's say, jet. So once they are melted, with the help of this jetting, they are removed. And the thing is that the width between these two parts is quite actually large. It's sometimes in between 1.5 to 10 millimeters. Another thing is that we may have such markings on the side surface. There's these actually flames, and that is actually that can be eliminated if you do, for instance, underwater cutting. So with the help of it, you don't need to have any kind of blanket or any kind of air around. You can simply perform this process underwater, and with this one, the quality is improved, and you may eliminate actually such let's say markings. And in addition to oxyfuel cutting, we may also use arc cutting. So with the help of these arcs, the heat will be generated, and again, temperature of the workpieces will be increased. They will be melted, and these portions, the heat affected zones, will be removed from the workpiece. And you are not, by the way, responsible for this part, the quality of the welds. And we'll be briefly talking about the selection, how we select the process, what are the types of typical welds. And that should be the next section. Yeah. So what are the type of welds? As you see, we have various types. If you consider joining two sheet metals side by side, we may simply use the ends of them and then do the welding. Or if you want to increase the actually cross-section area of the surface, the area of the surface, which is to be welded, maybe increase, and with that way, the strength of the welds may be a bit better. And these are called as V-groove welds. But for this one, we need to do little machining before this welding operation. If the workpiece is quite thicker, then we may have double V-groove. Again, if the gap is quite larger, then we may have some backing underneath. And for some T-like shapes, these are some options. As you see, bevel groove welds. For cylindrical parts, we have these options. And the simplest one is the butt joint, as you see, with little amount of maybe infill or with less increase in temperature, you can simply join these butts together. Or you may have some corner joints, T-joints, and left joint, another popular one. So in this one, we have more area, which is actually the interface in between these two parts. And lastly, this is quite difficult. These two parts are joined through an edge. And how we are selecting the best welding process, actually, you should have some information about these welding processes, and they are discussed in this chapter and the next chapter. And you should be careful about the type of materials which is going to be joined together. You need to be sure about warpage, other kind of distortions, whether they are harmful to your workpiece or not. So by having actually some knowledge on these welding processes, you can yourself decide on the best type of welding process for your specific project. And please make sure that you go through this review questions and qualitative problems, and see you in class.